Today in chemical engineering, we'll be looking at material balances on multiple unit processes. So the problem is over here. It's already been changed into a flow diagram for us, and there's no additional information other than we need to find all the flow rates and the composition. There's only two parts. There's A and there's B. Those are the two components. So that means we're going to have two material balances for each control volume we can make. So if we look over here, I've drawn some control volumes already. I've just arbitrarily picked 3. You can pick more than that. You could choose other ones. Depends on what you think will be helpful. If we look at the degree of freedom for control volume 1, we have 2 unknowns. So control volume 1, if we draw it right on here, is right here. So the only thing we don't know is M1 and X1. X1A. So in order to solve them, we could use the two material balances. We have A and on the total mass, or if we wanted to do, we could also do it on B. So once we do that, we'll be able to solve for M1 and X1A. So if we'll just cross those out, saying that we'll be solving for them. Then if we look at the whole process, which is in blue, we can see what enters and exits the whole process. Looks like stream 4 enters and stream 6 enters, stream 7 exit, and stream 3 exit. Out of these, again, there's only 2 unknowns. And that's good because we only have 2 material balances. So we have 0 degrees of freedom. We'll be able to solve for M3 and X3A. So if we cross those out right away. Last we need to do is solve for M2 and X2A. So if you look here, I wrote that you couldn't use this control volume here. Let's look why. So if we drew a control volume around these points, it contains our values that we're looking for in stream 2 never cross this. Only this stream here, 1, crosses, stream 6 crosses, and M3 crosses, and stream 7 cross, which means this will work out, but it won't show us any new information. In order to find new information, we're going to look at unit 2, a material balance around unit 2. So now you can see we have stream 2 coming in, and stream 3 exiting, and stream 7 exiting. So we have the 2 unknowns, M2 and X2A, in there. We have 2 material balances. So we'll be able to solve that. So let's look at actually solving it. For control volume 1, which was unit 1, we're going to take the total in, and that's going to be equal to the total out because there's no accumulation, and since it's at steady state, and there's no generation or consumption because there's no reaction. Solving for the values we need, M1 is equal to 60 kilograms per hour. Then looking at the A balance, we can take all the A that comes in stream 4, and that's going to be equal to all the A that comes out of stream 5 and all the A that comes out of stream 1. And when we rearrange and solve for X1A, we get 0.233. Then we do the whole process. As we said before, that's the order we're going in, so we can solve in order. If we do the total, it's everything coming in, which is stream 4 and stream 6, and that's going to be equal to everything coming out, stream 5, 7, and 3. Rearranging to solve for stream 3, or the only unknown, we get 60 kilograms per hour. Doing an A balance on the entire thing, we do the same exact thing, except how much A is coming in. So stream 4, this is how much A is coming in. Stream 6, how much A is coming in. On the other side, this is all the A that comes out. Stream 5, stream 7, stream 3. Then the only unknown is X3A. Rearrange and solve to get 0.0833 is the mole fraction of A, or the mass fraction of A, sorry. Then we can do the control volume 2, which is unit 2. We look at the total again, just like before. 2 comes in, stream 7 and 3 leave. That gives us M2 is equal to 90 kilograms per hour. And then stream A, we have what comes in for A and what comes out for A. And that gives us 0.255 mass fraction. So the problem's solved. But let's look if we made any errors. So we can do that by making a new control volume, which was around that mixing point, 1, 2, 6. If you look, we have 1 and 6 coming in, and that should be equal to the mass of 2 coming out. And when we do the math, it's true. The answers we got are correct. And then we look at A coming in and A coming out. We again see the same thing, that they're approximately the same, but since we rounded some of the solutions, those are the same answer. Be sure to check out more from chemicalengineeringhq.com. The links to the problem and the solution are down below, and feel free to leave me a comment. Thanks.